Part C of this question is an old favorite of theirs, where they put a line through the origin that divides the region into two regions with equal areas. And then they like to say, write but do not solve an equation involving one or more integrals whose solution gives the value of m. All right, so we're looking at our shape, and what they like to do is basically make you set up an integral that cuts the shape in half. So if I'm going to draw a line that, cuts the area in half like that, then that's going to happen at some angle theta. And if I call these two different areas, if I call them area 1 and area 2, then what I want is area 1 to equal area 2. So I like this formulation. I tend to set up my equation that way. The College Board solution instead says, let's just make sure that area 1 is equal to 1/2 of the total area that we already had up here. So you can do it that way as well. But they set it up that way. You can look at their solution. I like to set up A1 equals A2 because it sort of more literally reads what the problem is. All right, so then in order to do that, if I want A1 equal to A2, then I just have to have 1/2 the integral from 0 to whatever that theta is, r squared theta d theta equals 1/2 the integral from whatever that theta is to square root pi of r squared theta d theta. All right, so, but I can't leave it like this because they're asking us about the slope. I need to have an equation that gives the value of m, the slope. So I need to, instead of have theta, I need to somehow relate this to m. Well, theta is the nature of the slope. The slope is y over x, right? Well, that's the tangent of theta. So there are different ways you can look at that. The conversion from polar coordinates to rectangular coordinates is that x equals r cosine theta and y equals r sine theta. Therefore, y over x, cancel the r's, we get sine theta over cosine theta is tangent theta. But sort of more directly, I always think of the tangent of an angle is exactly the slope of the segment at that point. We've talked about that on the unit circle. The tangent is the slope of that line. The tangent is the slope of that line. All right, but the problem is I have theta here, and I want to replace that in terms of something about the slope m. So since m equals tangent theta, it follows that theta is just the inverse tangent of m. So all I have to do is replace that into this equation, and then I have 1/2 integral from 0 to inverse tangent of m of r squared theta d theta equals the integral from inverse tangent of m to square root pi of r squared theta d theta. And notice I've just used the formulation r of theta. I've never written out, I haven't written out this equation once during the entire problem because it's calculator active, so I don't have to. In this case, I'm not even solving it, even using a calculator. I don't know how I would, maybe some kind of weird graphical method. But all I've got here is an equation that says right here is my A1, right here is my A2, and they're equal. So again, I use this formulation, area 1 equals area 2. The College Board solution gives this equivalent formulation, A1 equals 1/2 A. The advantage is that their integral is a little bit simpler on this side. But by the way, I forgot my 1/2 there, so I would have probably lost a point if I didn't put that in. But anyway, it's 6 and 1/2 a dozen of the other because the two areas are equal.